Today we are going to start our new chapter, metals and non-metals. You already studied about these metals and non-metals in your previous class. We are going to discuss deeply about these two minerals and its uses. In our everyday life, these two, metals and non-metals, are very important. We know in our everyday life we use metals for many purposes. Metals conducting heat, so we use most of our utensils made by metals. And non-metals are insulators, so we made handles of these utensils by using non-metals. We made this pin using metal, and we use our chappal using non-metals, etc., etc. We can see many examples in our daily life by using metals and non-metals. So the metals and non-metals are very integral part of our life. We can't imagine a life without metals and non-metals. In our previous chapter, periodic classification of elements, we discussed about metals and non-metals and how it is classified in our periodic table, etc., etc. Apart from our day-to-day activities, day-to-day situations, industrially very important role played by metals and non-metals. Most of our industries works depending on metals or non-metals. For example, you may visit steel plants, many other metal-based factories making train parts, bogie parts, or bus, or many other metal used industries. Similarly, most of our factories works non-metal based industries, just like making fertilizers, wooden furnitures, etc., etc. So our industrial purposes also use metals and non-metals very integrally. All these metals and non-metals are obtained from minerals. Minerals are contained in our crust of our earths. As you know, our earth has three parts: crust, mantle, and core. Crust is the outer part of our earth. It is almost 20 kilometers deep in earth. All minerals contained in this crust of earth. We dig it and use it in our daily life. In this chapter, we just discussed from where we get metals and non-metals and how we use it and how we convert it in usable forms, etc., etc. First, we are just discussing physical properties of metals and non-metals. Physical properties of metals and non-metals we already studied in our previous class, so we just explain all this. By using these more physical properties, we can just classify metals from non-metals. But some metals shows the properties of non-metals and some non-metals shows the properties of metals. So we want to check the chemical properties also. We can check the physical properties. First, malleability and ductility. Metals shows malleability and ductility. What is malleability? Malleability is the property of a metal that can be beaten into thin sheets. You may see the metal foil, aluminum foil. It's a very thin metal sheet, just like our paper. We can beaten it to form into thin sheets. What is ductility? Ductility is the property of metal that metal can be turned into wires. You may see the filament in bulb. It's a very thin wire. These two properties are the properties of metals. Non-metals never shows these two properties, malleability and ductility. Listen carefully here. This malleability means the metal can be made into thin sheet by beating it. We can make non-metals to thin sheets, but using many other methods, not beaten into thin sheets. So, these two properties, beaten into thin sheets and thin wires, are the properties of metals. Another one is metallic luster. All the metals show metallic luster. That means a shining properties. Metals shine. When you cut a piece of metal, that part shows a shining property. Non-metal do not show shining properties. Hardness. Metals are generally hard. Non-metals are soft in compared to metals. Physical state. They exist in solid and liquid state. Metals exist in solid and liquid state. Non-metal exists in solid, liquid and gaseous state. Sonorous. Metals produce a ringing sound. School bell. You may hear bell sound. A ringing sound. Non-metals are non-sonorous. Density. Metals are high density and non-metals are low density. Imagine a piece of wood and iron. When we put in water, iron piece go deeper, it sinks, and non-metal float above the water. That means the density is very low. Electrical conductivity. Metals are good conductors of electricity. Non-metals are bad conductor of electricity. Also, metals are good conductor of heat. Non-metals are bad conductor of heat. These are the main properties of metals and non-metals. We can just identify an object is metal or non-metal by using some of these properties. If you see an object, you take another one and hit it. If you can hear a ringing sound, you can identify it's a metal. For example, we use gold as an ornament because of its metallic luster. We use metals to make train bogies because it is hard, etc., etc. We use to identify metals or non-metals by the physical properties. But there is some exceptional case. We can see what are the exceptional case of metals. Mercury is the only metal and bromine is the only non-metal which exists in liquid state at room temperature. Mercury is a metal, but it is in liquid state at room temperature. Similarly, bromine is a non-metal which exists in liquid state at room temperature. So, only one metal and one non-metal exists in liquid state at room temperature. Graphite and iodine possesses metallic luster, though they are non-metals. Graphite and iodine both are non-metals, but they show metallic luster, a shining property. Sodium is metal, is soft like wax and it can be cut with a knife. Sodium is a metal. You may hear about sodium in our compound sodium chloride. Sodium chloride. We discussed about the salt. That's sodium. Sodium is very soft. We can cut with a knife, just like we cut wax with a knife. Gallium metal would melt if kept in our palm. If we take an ice piece in our palm, it will melt. Similarly, if we take gallium metal in our palm, it also melts because its boiling point, melting point is very, very low. Gold and silver are the most malleable and ductile metals. Gold and silver is the most malleable and ductile metals. That is why we made a big chain by using a 2 or 3 gram of gold. 1 pound, we use 1 pound is 8 gram. If we take 2 grams, the goldsmith make a big chain because it's most malleable and a ductile metal. Diamond is a better conductor of heat than copper but poor conductor of electricity. Copper is a metal. It's a good conductor of heat. But diamond is a non-metal. It's a conductor better than copper but poor conductor of electricity. Graphite is the only non-metal which is good conductor of electricity but poor conductor of heat. Graphite is a non-metal but it conducts electricity, do not conduct heat. We use graphite in our dry cells, batteries. If you cut a battery, you can see a black rod at the center of this battery. It's graphite. It conducts electricity but do not conduct heat. Gold, silver, platinum and copper are found in free state. This is because of their poor reactivity as compared to other metals. Most other metals and non-metals we get as compounds. Just like imagine sodium. Sodium, we get sodium as in the form of sodium chloride from seawater. But we get gold, silver, platinum and copper in free state. We just purify it and we can use it. Okay. These are the exceptional case of some metals and non-metals. So, if we go through only the physical properties, we can't identify some metals or some non-metals from their physical properties. So, we want to check their physical properties also. And also, we quoted here that gold, silver, platinum and copper are found in free state. Most other metals are and non-metals are we get in compound state. So imagine we get sodium chloride from seawater by evaporating water. We take some water from sea and evaporate it, we get sodium chloride. Namak, in your daily use, namak. We want sodium from this sodium chloride. What we will do? Understand? What we will do? How we extract sodium from this sodium chloride? Or we want chlorine. How we extract chlorine from this sodium chloride? This is the many important part we discussed in this chapter. So that we want to know the physical properties and a chapter you already studied chemical bonding in your previous class. That also we want to know here and how we break this chemical bond and extract this sodium from sodium chloride. Similarly, iron, magnesium, zinc, etc. Most metals we get in compound state and we want to extract and purify it for our daily use. From our next class onwards, we can check the chemical properties and how we can extract metals from non-metals. You should go through this chapter, this part, because all these parts you already studied. We can stop now and continue our class by about the chemical properties of metals from our next period.